Okay, these are some homework problems from section 5.5, and these are solving trigonometric equations. And this was number 39. And if you look at this, it looks like we have a trinomial in sine of x, so we're going to use a z substitution. It's a little bit easier to see that, so we're going to let z equal the sine of x. All right? And therefore z squared will equal the sine squared of x. So then if I look at my equation over here, that's going to imply, we can just put over here, that this equation, the z equation, will be 2. And instead of sine squared, we got z squared. Okay, minus z minus 1 equals 0. And you can see I have a nice quadratic in z. And not quadratic, nice trinomial. It's a quadratic equation, but it's a nice trinomial that we can solve in z. And the only way we can get z squared is 2z times z. And the only way we can get 1 is 1 times 1. So we just have to figure out our SIGNs, our signs. Okay? And I think we can figure that out. It's going to be negative. So I'm going to have a bigger going to be negative. So we can try this, negative and positive, and see what happens. Let's see what happens here. Okay, so if we try that, we've got negative 2z plus 1z is negative z. Negative 1 times positive 1 is negative 1. And 2 times z is 2z squared, so that's what you've got. So now we can say that 2z plus 1 equals 0, or z minus 1 equals 0. All right? That's all right. And then if I subtract 1 and divide by 2, I get z equals negative 1/2, or z equals 1. Okay, then we can go back over here, and instead of writing what z is going to be the sine of x. Should have written that in blue. There you go. So then I'm going to write sine of x equals negative 1/2, or sine of x equals 1. So those are the two equations that come from here. All right? Okay, so we know the sine of x equals 1/2 when x is equal to, what equals 1/2 when x equals pi over 6. But this is negative, so this is going to be in the quadrants where the sign is negative. And that's going to be in the, not in the first quadrant, the second quadrant. Remember, all students take calculus. So it's going to be in the third and fourth quadrant. So that's going to be not pi over 6, but it's going to be 7 pi over 6 and 11. Oops, pi over 6. I'll read that, okay? All right, so 7 pi over 6 and 11 pi over 6. And when's the sine of x going to be equal to 1? Well, we know our sine curve, if you kind of remember, your sine curve goes something like this. And I think these are on the domain. These are all on the domain, so we should stipulate that up here. But these are on the domain from 0 to 2 pi open at 2 pi. So on this, our sine curve, this is 1. This is negative 1. This is 2 pi. That's pi over 2, pi over 2. The sine curve goes like this. So you should know where your sine curve is. You shouldn't. This is the way I do it. You can use a unit circle also. But this makes it a lot easier. There's your y. There's your x. So sine equals 1 right over here, and that's going to be pi, so it's going to be pi over 2. So I usually see those sine curves, I see those curves a little bit better. Okay? So that's 7 pi, and sorry for my writing, 11 pi over 6, okay? Okay, if that makes sense. That's terrible. I don't like that. Sorry about that. 7 pi and x equals 11 pi over 6. That's better. Okay? All right, so that's number 39. And then number 41, we have 2 cosine squared of x plus 3 cosine of x plus 1 equals 0. So again, the easiest way to kind of explain this is just use a z substitution. So let z equal, so we'll let z equal the cosine of x. So z squared will equal the cosine squared of x, or the cosine of x whole thing squared. Alright, so that's going to give us this equation that's going to be a little bit easier to recognize as a trinomial. 2z squared plus 3z plus 1 equals 0. So there you go. Alrighty. And then we can solve this, and again, this is going to be factorable. And the only way you can get 2z squared is 2z and z. And the only way I can get 1 is 1 times 1. And these are all positive, so my signs have got to be plus and plus. I don't have any choice there. And when you multiply that, you get 2z plus 1z is 3z, and 1 times 1 is 1, so you're all set. So you get 2z plus 1 equals 0, and z plus 1 equals 0. So you get z equals negative 1 divided by 2, and z equals negative 1. All right. So we can put that back into our cosine. So z is the cosine, so we can just say the cosine of x equals negative 1/2, or cosine of x equals negative 1. Okay, so we know the cosine of x equals 1/2 at pi over 3. Okay. All right, but this is going to be negative, so the cosine is negative in the second and third quadrant. Remember, the first and fourth is positive. All students take calculus. Okay, so we're looking at the second and the third quadrant. Pi over 3, so it's going to be 2 pi over 3 in the second quadrant. And 4 pi over 3 in the third quadrant. Okay. Negative. And then the cosine of x equals negative 1, and then again, you can look at your unit circle. You should know your graph by memory, I would hope. That's 2 pi. This is pi, y, x, 1, negative 1. That's going to be pi over 2, so you can put your marks in here. And the cosine starts at 1. So there's your cosine graphs. You should know that pretty. You should visualize it. That's all I do is I visualize these things so I can see what the values are. Now you could use the unit circle, and then you could use the quadrant angles, I should say. But there's the cosine. Nope, I should have been a little lower over there. Sorry about that. Okay. This goes over like that. But remember, 2 pi is not in the domain because the domain is 0 to 2 pi open, so we're not going to worry about that. So where is it at? It doesn't really matter anyway because it's only negative 1 there. And that's going to be what pi? Right there. And that's pi. Right in the middle. Okay? So that's easy enough. So there's a couple.